it's Actuary Dude here looking at another exam question. So an insurance company is modeling claim numbers on its portfolio of motor insurance policies using a Poisson distribution whose mean depends on the age and gender of the policyholder. So it wants us to find the link function for fitting a generalized linear model for the mean of the Poisson distribution. So the link function that would be most appropriate to it, just straight out of the notes, is this one right here. If it's Poisson, then we basically take the log of the mean, and that is the link function that we're using over there. So as you can see, if it's normal, it's not really, it's just equal to the mean. Binomial has a change there, and gamma is the inverse. So that's really all you need to do, just write down that bit right here. And for the second part of this, it's saying specify the corresponding linear predictor used for modeling the age and gender dependence as for A, where age plus gender. So what we'd be using is saying AI, where alpha is gender, and so I would be 1 or 2. You can say like 2 is male, 1 is female, or whichever order, doesn't matter. And then we'd also be adding in, you can say beta, which is the factor for age multiplied by, multiplied by the age of the person. And that's exactly all you'd have to find. And you can write down where I is 1 and 2. The other way is they're saying do age plus gender plus age times gender. So what we're doing here is we don't need it doesn't look as complicated as it does in the question. We keep this bit over here. Alpha dependent is basically the gender. And then all we're doing here is making age dependent on gender as well, because over here it didn't matter if you were male or female, you would the age would still affect each gender in the same way, and then there's the gender bit over here. Whereas for this one, age will affect each gender differently, and so that's why we have beta I multiplied by x. So that's all you have to do, and you can still again write down where I is 1 or 2. And that's really it. That would be the linear predictor in terms of doing that. Thank you very much for watching.